So the first thing to decide when naming a compound is what kind of compound you have. Is it ionic, is it covalent, or is it an acid? We need to know that first because the rules are different for these three kinds of compounds. So right now we're going to talk about ionic compounds. To name an ionic compound, you have to have two parts. First, you have to have the name of the cation, and then you have to have the name of the anion. And if you have trouble remembering those two words, just think of the T in the cation. Kind of looks like a plus sign. And in place of the T in anion, we have an N, which is N for negative. So the cation is the positive ion, the anion is the negative ion. And we have to put those two names together in two words. They're separate words with a space between them, and that's the name of our ionic compound. So there's three kinds of cations we might deal with. A simple ion. So we might have calcium ion, which we look at the periodic table and decide it's 2 away from a noble gas going to the left, so it's a 2+. And we would simply write calcium. So that's all we do, just write the name. The second kind is a polyatomic ion. Now this is just about as simple. You just write the name, but in this case we have a little more complex situation because we have a group of atoms that have a charge, and so the group has its own name, ammonium. So we just write the name ammonium. Or the third kind that we can have, the third kind of cation, is a variable charge metal. Now, in order to know what things are variable charged metals, you really kind of have to look it up, but here's a rule of thumb. Transition metals, for the most part, are variable charge, and metals under the stairs, under the stairs. Now, by the stairs, I mean that dividing line between metals and nonmetals. Now, that isn't true for every single transition metal, but almost all of them are like this. So, we're going to write the name, but now, in parentheses after the name, we're going to put in a Roman numeral for the charge on that ion. So that will be something like iron. If our iron atom, instead of being an atom, is an ion, and it has a 2+ charge, then we would write iron, Roman numeral, right next to it, 2, because the iron has a 2+ charge, and close the parentheses, and that's the name of the ion. It's an iron 2 ion. So there's three kinds of cations we might have: the simple ion, the polyatomic ion, or the variable charge metal. Then, so that's the first word we write down. The second word we write down is the anion, and again there are different kinds, so let's talk about them. We have a simple ion, and this could be something like chlorine. So chlorine as an ion would have a -1 charge on it. We know that because it's 1 away from the noble gases going to the right. So we would write chloride. Now, chloride is not the same as its name. So notice with our calcium on the cation side, we just wrote its exact name, but here we're going to change the end of the name to ide. Instead of chlorine, we're going to write chloride. Oxygen, 2- would be called oxide. We take the egen off and write the ide. So the second thing, the anion, if it's a simple ion, we have to change the end of the word to ide. So that's our simple ion. Then we might have a polyatomic ion, most polyatomic ions are anions, not cations. So we might have a polyatomic ion, and then again we just write the name. So if it is NO3-, we look that up in the table if we haven't got it memorized yet, which you're going to have it memorized, right? And we find out that's nitrate. We don't change the end, we don't do anything to it. All we do is just write the name down. If we have CN, cyanide, that's the name. Cyanide is the name, then we write it down. So that's the other option we can have for the anions. Now, the only other thing you need to know is that when you're going backwards, not going from formula to name, but when you're going from name to the formula, be sure that you make them add up to 0. The charges add to 0. For instance, if we have calcium 2+ and chloride minus, we would need to make that calcium chloride with a calcium and 2 chlorides so that the 2+ and the 2 1 minuses, so there's a calcium, what that means is there's a calcium 2+, there's a chloride 1-, there's a chloride 1-, and if we add up all of those charges, the 2+, the minus, and the minus, that would add up to 0, which is what we need. So our formula would be calcium chloride.